Hi friends, welcome to Unit 3 Day 5 Notes. We're graphing. So we're going to be graphing this number 9, g of x equals x plus 1 over x squared plus 4x plus 3. The last example didn't have this, but now I have a term in the denominator that I can factor. I'm going to go ahead and do so. So the factors of my numerator are 1 and 1. My factors of my leading coefficient, and then my factors of my constant are 1 and 3. So I know that this is going to be g of x equals x plus 1 over x plus 1 times x plus 3. Now that I have this, I can go through each of my parts. Step 1, find the vertical asymptotes. We do that by setting the denominator equal to 0. We do that by setting what's in the denominator equal to 0. However, in this case, we actually have something that cancels. The x plus 1 in my numerator and denominator cancels. That means I'm going to have a hole in the graph. So to find out where the hole is, I'm going to abbreviate vertical asymptotes VA just to save on space. VA. All right. So that's going to be set x plus 1 equal to 0. So I get x equals -1. Then I plug -1 back into my simplified fraction. So my simplified fraction here. So that's going to be y equals 1 over -1 plus 3. -1 plus 3 is 2. So I have 1/2. So I have a hole at -1, 1/2 is 0.5. So I'm going to have a hole there, -1, 0.5. And then my other vertical asymptote, if I set x plus 3 equal to 0 and then solve, I get x equals -3. So I have x equals -3 as one part of my vertical asymptote, and then the other is a hole at -1, 0.5. Again, I'm going to do this in a different color, my asymptotes. So -3, 3, so here. So there's that part, again to show that's not part of the graph. And then also this hole here at -1, 0.5. Again to show that that's not part of the graph. So I'm using blue to show that that's not part of the graph. Next thing I'm going to do is find the horizontal or the oblique asymptotes. So this is where I check for the degree. The degree of the numerator is 1, the degree of the denominator is 2, so the denominator is greater than the degree of the numerator. If that's the case, then you always have a horizontal asymptote at y equals 0. So there's my horizontal asymptote. Next part, find the y-intercept by evaluating f of 0. So my y-intercept, I evaluate f of 0, which in this case is not f of 0, it's actually g of 0. G of 0 is equal to, so I have 0 plus 1 over 0 squared plus 4 times 0 plus 3. So simplifying all this, so this 0 plus 1 is 1, 0 squared 0, plus 4 times 0 is 0, I have 3. Essentially everything is canceled out unless you have constants. So my y-intercept, and this is part of the graph, remember this is actually part of the graph, is at 0 and then 1/3, or if you put 0.3 repeating, you're correct. Don't just put 0.3, that is not correct. So it looks like, as imagined, it's down there, really close to where the x-axis is. Again, not touching, close to it. Find the x-intercepts by finding the zeros of the function. So here, so my x-intercepts, so I have g of 0 equals x plus 1, 0 equals x plus 1, minus 1, minus 1. So I have -1 equals x. Now this should give us a red flag. And going through and doing this, we're going to get x equals, wait a second. So be careful in this scenario or this case. You can't cross the x-axis if you're not actually, if you have an asymptote here at the x-axis. So this is why this created this little like blip here, this little note, is that you can't have x-intercepts if you have a horizontal asymptote at y equals 0, most of the time. So in this scenario, you can't have x-intercepts if your horizontal asymptote is y equals 0, because you can't have y equals 0 being an actual valid part on the graph. That's why it came up as a whole. X-intercepts, determine if it will cross the graph. So does it cross the graph? Generally, we'll find out by plugging it in. So we have 0 equals, where do we plug in? 0 equals -1. This scenario, or this case, it comes out to not be the case. Let's plug it in. We end up actually with where our hole is. Gathering my thoughts. 0 equals, so y equals 0, 0 equals, I was looking way too far up. It's like, I can't find it. X plus 1 over x squared plus 4x plus 3. So when I multiply both sides by x squared plus 4x plus 3 to get rid of my denominator, I'm just left with, let's show with a different color. Keep the color. So when I multiply both sides by this, when I multiply the left-hand side by that x squared plus 4x plus 3, what happens is I get 0 times the 4x squared plus 3, so I just end up with 0 equals x plus 1, which is very similar to what we have up here finding the y-intercepts. That's where the hole is. So that's why we're getting a lot of this discontinuity here with this x equals 1, because it's already where there's a hole in the graph. So no, even though we got x equals -1, no, there's a hole there already at x equals -1. So it can't cross, there's already a hole there. And then we need to plot selected points. This one's a little bit tricky. We just have 1 point for the graph. We don't have any other values. At this time, I would just grab a t-chart and plug in values so I can fill in for each part of the domain. -1, 2, 3, 4, 5, 6. I'm going to plug in -6, -5, and -4. That'll give me these values. -3. No, not -3, excuse me. -2. -3 is where the asymptote is. -2. -1, there's a hole. And I already have that value here. So I kind of already see the shape. I'm just going to go ahead and verify by plugging in 1 as well. All right. So by plugging in each of these values, I'm going to end up with my y parts. So plugging in -6. Here I'm just going to grab my graphing calculator and plug it in. Again, time for this particular video. So I have parentheses -6 plus 1 close parentheses divided by -6 squared -6 squared, there we go, plus 4 times -6 plus 3, there we go. So I get -1/3. I'll do the same thing except for -5. To do this, again, I did second answer, or second entry. That's -1/2. -4. -1. So each of these points, -6. 1, 2, 3, 4, 5, 6. -1/3, so that's close to there. It's close to there. It's close to there. So what this side is doing, again, it's getting really close to that. It's going to get really close to this. Now for the other side, plugging in -2. That gives me a 1. And then plugging in a 1. gives me a 1/4. So that's there, and that's there. Again, I'm not drawing through that hole there to show that it continues on. So, there we go. There's the graph. Again, the green is the graph, and the blue is the asymptotes. Talked about in the last video, but just to clarify, or the hole in this case, just to clarify, blue is not the graph, green is the graph part. So if you were just using a pencil, you would want to erase this area here. Generally, if you're just using a pencil or one single color, you make the hole prominent, stand out. Usually you label what's happening, that way people can easily visually see what's going on with that graph. All right, have a wonderful day.